Right on. So Bernard, how are you doing?
I'm doing very good in yourself.
Really good, thanks. Yeah, thanks for coming. Again, thank you for coming to the podcast as a guest speaker, being a subject matter expert in the pipeline space. Can we give our listeners a quick overview of what pipeline project scope usually is involved?
Well, I've been in the industry for about 24 years now, and pipelines, I usually say, are you get a product from A to B, and anything in between, for example, pump stations, metering facilities, that's all within the scope of the pipeline. So on top of the steel or the HDPE or whatever material the pipe is made out of, we need pumping stations, metering facilities, and that's usually in the middle and in the end. And that's what the scope involves.
Right on. So typically, like you mentioned before, so there's a lot of things involved in the pipeline design, right? Like from your experience, what you have seen in industry and other, industry peers like they have done. What are the general misconceptions about pipeline design? Is there any examples that you can share with their listeners so that nobody can repeat or somebody can learn from sort of like your experience?
I think people, they underestimate what is really required. They think that all pipelines are the same. And, if you did one project, it should just be what we have as a cookie cutter for all projects. But I could tell you in my experience, it's been, you always have a difference in a product. It's always different. And, the calculations are the same. Usually the codes are the same. But every project I treat as unique, and that's the way to treat it. So the misconception I would think is people think, oh, we did a pipeline before in this one area, let's just use it for this area now. But maybe that past area had muskeg, maybe it had more crossings, maybe, so there's a lot of variables that people take for granted that they think is automatically in every pipeline, and it's not. So we have to take a project, take it as a unique entity, and we have to evaluate it and take it from there. So when it comes to scheduling, for example, they think, oh, that project took 6 months to do. This one should take 6 months. But again, so many other variables. Maybe there's more crossings. Maybe there's so many other factors that every project has to take into account of. So I think underestimating the timeline it takes to do a project.
Yeah, I remember that you were saying about some of the environmental factors as well too may delay the process of a permit application, and
Exactly.
the density of the population can play a factor as well too, right?
Yeah, some land is crown land, easier to cross, and some land is private land, so that you have to negotiate. So a lot of negotiating might be needed in one project. And environmental for the crossings, if you're going to be crossing river bodies that are named, then there's the environmental factor that it'll take 3 months to get through. So again, lots of variables, and I think people just, they take it for granted what's really involved to get it moving, to get that project moving forward, the work that's required.
Yeah, like if there's any examples that you want to share with us, just, pick one of the projects, you've done before, and then was there any major mishap, for the lack of better terms in here, and then that causes the project kind of turn it upside down. It's not what the client expected. Is there any an interesting story that you can share with their listener?
Well, I wouldn't name the clients because just out of confidentiality, but we were literally doing what we call, it was a simple horizontal directional drill, which is HDD. So a horizontal directional drill up, it was a slope. It was pretty steep, but we had in the budget what it was going to cost to do this bore, and it turned into a nightmare. The drill fracked out, and I think it's because we were going up so steep. We lost fluid pressure. We lost, and when you lose fluid pressure, that fluid went somewhere, and it turned out to be a nightmare for that job. The cost went from, I think it was $100,000, 200,000. It was about $200,000 bore. It was a really short one. It was incline, but it turned out to be $1 million when we were done. So, the client wasn't happy. Once again, we thought we took all the precautions, but that was a job that we believe we should have done a site visit to. We went basically off of photographs, historical, what people said the area looked like, and we took it for granted. So we went, okay, that should be a simple bore. We got some bids in, and they said, yeah, we'll do this bore up this hill, and it turned out to be a nightmare. We lost a lot of fluid, and fluid has to go somewhere. And I think the bit, we lost a bit at one time. And this was so, if you looked at this drawing, Marco, on just a piece of paper, it was the simplest job. We underestimated what it would take, and it went to $1 million. It was $1 million. And the client went, absolutely berserk. They didn't hold us accountable, but, in the end, they were pretty choked on a price going tenfold, right? So.
Yeah, I think the words of cautions to our listeners, like who may be like in charge of client stick, for example, is that it can be anything that can happen, to the project. And you can't really single outline, one single scenario is we can mitigate the risk, but then a lot of factors can come to the plate as well too. So that's a really good example there. So typically, what kind of conversations do you normally have there with the clients who want to build a new pipeline? Whether like you mentioned before, there are certain things they need to keep that in mind as well too when they go to their bosses to ask for funding to build this job, for example. And how can we help the clients to understand better so that they can actually approach to their management teams this is how we should do it, or this is how we approach it?
Yeah, usually the client, they already have their business case created, and they have a certain amount of funds that are allocated for us to do what we have, the pre-feed and feed studies before a pipeline is. So they'll have a number. They'll say, okay, we're going to build a pipeline from A to B, and we have these costs. And then that's when they approach us. And our job when they come to us is to see, number one, is it really feasible what they want to get to A to B? Then we kind of look at all the other types of variables. We try to start looking at the routing. We try to see if there's a better way of routing the pipeline. Is there other facilities they can utilize? So basically, we take what they have, evaluate it, and then give them our recommendations. But these, the clients that we've dealt with, they usually know what they want in the business case. They have their, it's not their first dance. They know what volumes they need to get, where they need to get it. And our job is just to make sure that it is feasible, that we do the engineering design to get those volumes that they need where it has to go. So they know they usually know they want to get something from Fort McMurray down to Edmonton. And we have to find out, is there an existing right-of-way? Is there existing corridors that are available to them? And we bring that up. We bring that, they might say, hey, we want to have 2 lines. And we might say it's optimized if you do maybe a single line. Or sometimes you do need to have, if you're going to be dealing with a pipeline with a certain distance, why don't you put fiber optics already for future jobs? Why don't you put in an additional line at a bore crossing? So those are things that we could bring up to them. We could say, hey, if you're going to be crossing this river that's going to be a kilometer bore, why not put in another secondary line while we're doing the bore? We'll pull the line in and you cap that line off for future. So those are the things we look at that the client goes, hey, that's a good idea. That's usually a good idea.
So essentially, it's fair to say it's more like a code eye review as well too?
Yeah. Usually, we have a standardized code. We don't try to reinvent the wheel, right? CSAZ 662, now we're at -19. That's the Bible. So we don't try to go out of that. So what we do is we try to just maximize pipeline sizes, wall thicknesses. We try to find cost savings in our design as per CSA. Can we safely transport that product? So, if we could try to minimize the wall, we could probably change the grade, maybe increase the grade and lower the wall, or increase the wall and have a lower grade. So we could go back and forth, but as long as if it's within code, we can find the optimized size for that pipeline, right?
Right on. So as an engineering consultant like yourself, your job is to help the clients to translate that conception stage from the client's perspective. They already know that they need to transfer this product, from point A to point B. They know that, the volume, like you mentioned, and all the temperature, and then the geographic locations and all that. And then your job is to help them to understand better from the dollar perspective and also the physicality of the actual construction and everything else.
Exactly. And I'll tell you from my latest experience, we find that the clients themselves sometimes they're so big, some of these companies, they don't understand their standards and specifications, their own standards and specifications. So I'll give you a quick example. We were doing this pipeline up north. I'll keep it up north. There's only a few producers that are up there, so you can kind of, eliminate them. And usually when we do a standard excavation to put, a trench or a ditch, we could call it a trench or a ditch to put the pipeline in, you could go at a 2-to-1 slope. But this client, they had in their specification, because of the area that we were in, it was a 3-to-1 slope. This 3-to-1 slope for the pipeline size, it's almost impossible to build because you can't even reach over to the center line to lower the pipe in. So the cost that we had, we just assumed a normal ditch line and a normal burial, which we normally do, about when you're getting to frost line, you go a little about 2.6 meters. You're usually safe if you have any kind of information about the area where the frost line is. If you don't have it, this client had particularly, if you don't have this information, you have to go 3 meters deep. So imagine 3 meters deep and you have to go at a 3-to-1 slope. Marco, this thing was like 40 meters wide. Can you imagine? 40 meters wide. So the center line was 20 meters. If you could imagine the boom on a pipe, the booms trying to lower this pipeline in, it was going to be a nightmare. It could be done. It's been done before, but the client did not understand their own standards and specifications for that area, the particular area we're in, and the cost went up. And they weren't expecting those costs until we pointed it out. We said, hey, your own standards say you have to be this slope. And they were just, they couldn't believe it. So that's an example of something else we have to look at. Sometimes we have to educate the clients on their own standards and specifications when we get this project that they want to do. And that's our job. We go through we get standards for piping, electrical, the whole gambit of what we believe is needed to build this project, and we evaluate it. And we bring a lot of things to the attention of the clients that they never know. They do, what? We didn't know that. We did not know. So that's it.
Yeah, totally. Sounds like you guys are definitely on the client side, and that I think that's a very genuine statement as well too. My understanding from our previous conversation before as well too, that you have helped different clients to develop their own standards as well too, right? So can you share some of your experience with our listeners as well? How do you go about to develop standards, like for clients, that may need to change or deviate from their typical standards?
Most clients will have a deviation process. So if we come upon, a standard that we believe it's unnecessary to go 3 meters deep because we actually built a pipeline similar in the same area and we went only 2.5 or 2.6 meters deep. Believe it or not, that extra 400 millimeters helps, right? So they usually have a process, and it's usually a lengthy process, and that again is part of a risk. So we found for certain clients, we actually have to identify in the risk their own internal workings of the company to approve these standards and technical deviations. Most Canadian companies we've worked at, they have their standards pretty well locked down, and they look similar. So maybe, when, it's been an old industry, people copy a standard, take it over to another one, bastardize it. We find that the US clients, though, they're up and coming, and they have requested that, I evaluate and come up with standards for how do we install HDPE. Most of the HDPE standards right now are built for utility piping or, in your neighborhood, in a residential or in a city setting. But is it really practical how they want you to install that pipe in the city setting for a cross-country setting?
Yeah.
So, in most standards right now for HDPE, it says, you could only string 700 700 feet of pipe, and then you have to install it. Or they talk about installing in a ditch. That's not practical up here. We're putting people in a ditch. What we do is we want to string as much pipe as we can. Then we lower the pipe in after it's fused. Most of the standards now for HDPE, because they're residential and based for putting stuff in the city, they have you fusing in the ditch. Not practical, right? Especially when we're dealing with big pipe. If we're dealing with 24-inch, the fusing equipment to put in a ditch for every joint, let's say every, whatever is coming off that, it's not off a reel when it's that big, but it's not practical. So when the clients in the States were asking us, how do we put in an HDPE pipe cross country? We were to take what was in existing standards and we made it for cross country. We said, hey, yeah, you could string the pipe longer, or you could do all your fusing above ground and lower the pipe in, and then, versus what the standards had. So the American clients, they're the ones, they do have a very good code. They're two B31.4 and B31.8, excellent codes, but it really doesn't tell you how to put that together. So they use another standard, which is I think it's PIP, or, I forget the organization, but that standard is really, it's for utility piping. It's not for cross-country piping. So we had to adapt it.
Right on. Okay, wow. Sounds like, there's a lot more to consider when it comes to like, not just like a typical standard design. Like there's a lot more factors like an aspect, like all the clients or, the pipeline operators, owners that you have to consider as well too. So that's great. So, we have, like in the industry there, it seems like, there's influx of like, people who are experienced and whatnot. So there are a lot of people, there are a lot of clients that, coming from the industry, from the school, they're not, as experienced, like, as the veterans like yourself, and then some of your colleagues as well too. So would you be able to share some of the typical mistakes that you've seen, like from, like we have talked about it before earlier, just highlight maybe like 3 or, down to like 3 bullet points, like what are the things that, like these are the things, like always see people making the same mistakes all over again. So can you highlight those to our listeners?
In regards to the age with the veterans, I think right now we are seeing a big gap in the industry. It seems like to be called a project manager back in my days, you literally had to have minimum 10 years under your belt. Now it seems, because the veterans are, they're either retiring out or, they're moving on. This gap has to be filled, and we have found that there has been a group of, once they get their PE or their PN stamp, which is, after 4 years of work in an area.
Job training, yeah.
Yeah, they suddenly, the companies have this void, so they make them instantly, they become project engineers. And then, I started off, I was, technical support for the longest time, engineering support, before you became that project engineer. But now they come right out after 4 years, they're project engineer. And within probably 2-3 years, I'm dealing with guys that I've been on projects where the client, they're basically, I look at them at my age, I think everyone is a kid. So they're kids basically telling us what to do, and they don't really know what to do. So how do we handle that? We actually treat them as if they were our engineers in training and younger engineers. So it becomes a mentorship. Suddenly we're mentoring these clients because they're making very, I don't want to say mistakes. They just don't know what they don't know. Yeah. Right? They have they can read anyone can read a code. Anyone can read the codes.
Yeah.
But it's how to get where they have to get. They don't understand. I could visualize, and most older engineers, they could visualize what it takes to set a valve. You could picture that picker truck, you could picture a crew, and you could go, hey, there's 3 guys needed to put that valve in. So I would say 3 guys, and they could get that done in a day because it might be a 12-inch valve. They have to bolt it up, blah, blah, blah. I know, and that's how I could build my estimates. Whereas the younger guys that we found, they come in with, for a cost estimate, they come in with factors. Oh, that's a factor of 2. We're like, well, what does a 2 mean? So they're trying to translate my 3 guys with a picker truck. So I have to have the truck cost, the guy cost. I have to have the subsistence for each of those guys into a factor that someone came up with to kind of balance it off. So where I find mistakes are happening is the younger guys, they don't know what it really takes to put some equipment in or to actually build something. Whereas the older guys could visualize that crew. You can see that crew, what it takes to do it. And so that's what I think what they're estimating. And that leads into estimating is always tied into scheduling. So it affects their scheduling. And I'll tell you the simplest mistake I find with scheduling. We'll get a schedule for the clients. You know, the first thing I do with a schedule, I put in all the holidays.
Yeah.
Before when I set that, I put in Christmas, I put in Thanksgiving, I put in all those holidays. So I would get a schedule from a client and I'd say, can you send me the live version of this? And they put in, 2 weeks to do this. And they're right into December 26th. They're right into, and I just take it and I will change it into Microsoft Project or Primavera, whichever version they want to set. And I would set the schedule. I would set the week and I would say, hey, there's Christmas break here. We're going to have at least 2 weeks off. And you would be surprised at their faces when they see how their schedule gets pushed out. They're like, oh my God, we wanted to start off January 4th. Well, you can't now because you didn't take into account Christmas. You're January 20th.
Yeah, exactly.
So that's a big one. And also in scheduling, they forget to change the work periods. Most people they'll have a normal standard work day, right? I work 5 days a week.
Yeah.
When we're constructing, it's 7 days a week. You don't even say, oh, it's 6 days. No, crews work 7 days a week and they might do 12 hours or they might do 10 hours. But when you put that in, you could tighten up actually the schedule when it comes to construction because they might go, oh, that takes 40 days. And then when we put in the change in work times, it suddenly brings it up to 30. So those are little mistakes, probably the cost estimate and the scheduling. But, everyone, like I said, they could read codes, they understand codes, they know what it takes. But when we get little things that will affect the overall project, that's the things that they miss because they don't have that experience, I can give you one last example.
There are 2 I think you mentioned before as well.
Yeah, so check this out. So the client had these massive battered piles and battered piles of piles that are put in at an angle to hold this pipeline because the stress analysis showed that the pipe was going to just move. And they had to hold this pipe. They had to anchor the pipe. They wanted to anchor it. And I have a philosophy where if the pipe wants to move, I let it move, right? I do let it move. So they had these battered piles, and where the area is to do a battered pile up north, mobbing a crew, you're looking at, on average, about $2,000 a pile. Yeah. Not counting mowing, and you got to mow the crew in the piles, right? So $2,000, and I think they had about 20 battered piles. So took a field trip, went up there, and I said, okay, so we're going to anchor the pipe right here with these battered piles. And they go, yeah. I said, and that's the trap over there. And they go, well, yeah. So the trap was about 20 meters away. So what I said, why don't we just come above ground here, put an above ground expansion to the trap? And they're like, we can do that. And I go, well, yeah. So instead of putting 20 battered piles, you just put normal pipe supports with a nice expansion loop above ground, problem solved. Up to this day, that was like 20 years ago. And the system's still in place. Pipe is looking nice, no problems, right? But that's experience because when we found out, when we dug into it, the engineer that did the pipe stress was never out in the field to know what it costs, right? They didn't understand the cost. The first thing I hear when I hear piles is, man, I got a mobile crew. I got to shut down equipment, right? If it's existing equipment and you try to bang a pile, you're going to mess up the meters. You're going to do so much things that are involved with just putting a pile in, right? So that person, imagine putting in all those battered piles. It takes forever, number one, to do them at the angle. But experience right away in one day, we solved the whole thing. We probably saved them a lot of money, right? So that's another thing. Not that they don't know. They just don't know the other things they don't know. They don't know, they don't know.
Yeah. That's crazy story, Bernard. Yeah.
So that's a trick.
So because it sounds like it's not just like like a technical engineering support that you're giving. You're like giving them mentorship. You're giving a lot of project management, one-on-one on the little details like that they never got to learn, right? So like if I were to ask you, Bernard, like turn the table around, back in the days, what was the one thing that you were advised on until nowadays that you still remember? And then that's the message. Like I think you want to pass it on to the next guys, for example. What was that one thing?
Never send an email in haste. Sit on that email for a bit, right? Sometimes the clients, remember, we have to think about, they have deadlines and they have people coming down their throat, right? So it all comes downhill. And sometimes they might be in a little bit of a, they might be under a lot of pressure, and they might send an email that sometimes, and it's happened to me, where they might actually say, hey, what kind of crew do you have? What kind of engineering team do you have put together? Are they amateur? Like they will actually almost, in a little subtle way, almost insult it because we're not giving them answers as fast as they're being asked answers when they don't know it takes time. So sometimes when you get those emails, you just want to write an email and say, hey, back off, give us some time. But you have to negotiate. You have to remember negotiating skills, right? So we have to usually calm the client down, let them know we're doing as best as we can. But I learned, just don't send that email right away. Let it sit. Talk to your team. Let them know if the client is valid, right? Maybe, I'm waiting for some electrical drawings or something on the P&ID didn't get changed. And the client was asking for that and I didn't know about it, right? As the project manager, maybe that call went directly to the project engineer. Once again, there could have been a break in command. And that's another thing I should mention. The chain of command is what I learned well. You have to stay out of things. You have to keep your chain of command. If you're talking to the client, that's the way it stays. Keep that the way it is, or things that start to break down. So that's, I think, just don't do things in haste. Just remember, settle back, relax, because when we built pipelines in our days, we didn't have cell phones. Right?
Yeah.
So things didn't happen like that, right? Clients are, where's that email? It was faxing. We were faxing sketches. We were doing, right? And it still got built. It still got built, right?
So fine. Right.
So when they expect that immediate answer, take a step back, go have a coffee, think about what you're going to do. If you need someone to just look over that email, see how it comes across on the client, because you do not want to be defensive, right? When you come across as defensive, then they start to be defensive, and it just takes things to another level, right? So just don't then send things in haste.
That's great advice. Yeah. Great advice, Bernard. Thank you. So you mentioned before there's like, different codes, like in Canada, US, and somewhere else. I understand that, you have executed many different pipeline projects in your career outside of Canada and for example, Australia and US. So can you quickly go over some of the design criteria in different regions and just a very high level, and then so that, like our listeners can, well, actually there's differences between different regions in terms of code. So they can, dive into it as they wish, right? So particularly when there's maybe a different temperature factor, right? So if you highlight some of these examples.
I would think that's the biggest one, is that temperature delta T that we deal with. Typically in Canada, we have, when we're designing during the year and we want to start to construct in the winter months, because we deal with a muskegee type soil and we don't want to lose equipment. So our timing is always lots of design up front, and then come around November, just before Christmas and after Christmas, that's our big construction window. And how other codes handle it, I will be honest. I think the American codes, the B31, 3 and 8, now we have one CSA standard that covers everything. We cover liquid, gas, all in one. It's all encompassing. CSA Z662-19. That's our pipeline transmission code. In the States, they have two. They have a B31-3, which is facilities, B31-4, which is liquids, and B31-8, which is gas. So you have to always know which code you're actually dealing with, right? So you have to go in where it takes over, but they all deal with a delta T. They do have that install to design, but it's not as drastic as ours. Except in Australia and maybe in Texas, what happens, we have a delta T where we are putting the pipe in the ground at a very low temperature, let's say minus 35 degrees C, or, well, we can't because we can't well past minus 25. So we use our delta T at about minus 25 to operating. Now we install at a cold temperature and we also operate at a hot temperature. So we have a very big delta T because we have to keep our product warm or it will thicken up, right? Because we're dealing with a bitumen type project. So when we mix things, it becomes a hot bit product. And to keep the temperature down, we usually add a condensate. So it becomes a dill bit, which is a diluent. So our costs are really high because of that operating range. Now in the States, what do? They usually construct in the really nice summer weather and they operate, so their delta T goes the other way. They're installing at a hotter temperature and operating actually at a cooler temperature than the installed temperature. Australia, they also have a delta T formula in there. I don't want to get any technical. We could discuss that later on other podcasts about the technical, how we calculate that. But Australia, because they try to keep their footprint down, this is really strange. They actually like to install pipe. If we had 3 pipes in a ditch here or 2 pipes in a ditch, they go side by side and we have a spacing requirement. Australia, this is weird. They will put 1 pipe in a ditch and 1 above it. It was really weird because they want to keep their footprint down. We're like, how would you ever repair that line?
Yeah.
You need to repair it, right? Our lines are side by side, but that's how they minimize their footprint. They like, maybe it's changed. The last time we did that was back in, when were we down there? 2015 or, maybe I heard the AS2885, which is their code, AS2885.1. They were going to combine it with some other codes. So maybe it's changed, but back in the day when we were down there, we had our nice right-of-way with the 2 lines side by side and everything was looking good. And they're going, no, we want to put them on top of each other. And, there's nothing in the code that says you can't, even in Canada. It's just not practical. But they didn't see that. They were like, it's low pressure because we're dealing with a little gas system. It's low pressure, one on top of the other. There'll be no problems with excavating.
Does it save money, like to actually, because they're digging just thinner trench?
Yeah, that's their whole thing was we have a smaller footprint. So instead of us having, like a 10-meter right-of-way or 50-meter right-of-way, they reduce it to it's almost like 5 to 10 meters. So that was just their environmental kind of footprint thing. Australia had very rigid environmental standards, believe it or not. They did. So like I said, there's nothing wrong with doing it. There's nothing in our code right now in CSA, said 662, that says the pipes have to be side by side. It gives you a spacing for pipe. And that spacing doesn't say whether it's on the top or the bottom, but we know for practical reasons here, we usually have 1 line running next to it and the other line running, and that's how we build. They did it a little bit different. They didn't mind putting 1 pipe on top of the other, which is, to me, it'll have to be a deeper ditch because you still have to maintain. They had a minimum cover requirement as well. And that's another thing. They were able to take their code, and there was a sentence in there that was able to manipulate the minimum burial depth to a shallower depth if they wanted. So they had some shallow pipe that we were going, wow, that pipe is shallow. And they had this little clause in the code that said it was something to the tune of, if not practical, that kind of line. If not practical, they could go shallower. And that's what they used all the time. So when we have a minimum 1.2 meters is what we like to put our pipe at. Even in CSA, it's, depending on the area, but 1.2 and sometimes 2 meters when you're in a facility, you stay about 2 meters. They were even shallower. So
interesting stories. Like I think our listeners,
I hope it changed.
Forward to listening more like those interesting stories like in the future episodes. So the next questions in here is it's a little bit controversy, a little bit like ongoing debate between whether to transport the products, whether it's crude oil or gas or whatever, between the pipeline and rail, right? Or even truck as well to transport the products, like from point A to point B. So in your experience, can you help our listeners to understand, highlight some of the benefits, why does sometimes like one is not necessarily better than the other one or vice versa?
I see no benefit to rail, and I understand why they sometimes truck, but buried pipelines are still the safest. It's almost like how they say flying is the safest way of travel, except when a plane goes down, it's pretty catastrophic, right? So with a pipeline, remember anything that goes wrong, it's you're able to contain it. There's not going to be, when you hear of a rail car offloading improperly, like it falls off its tracks, it's usually catastrophic. It's usually around a town. It usually pollutes the water systems. Rail cars, how you load and how they transport, I can't say how that design prevents what happens. But I can tell you when it comes to pipelines, I have a lot of tools available to me. I could design a pipeline with a thicker wall. I do not. This is not school where you try to find the thinnest wall and the most optimum grade. If you find, as a designer, as an engineer, you have to sign off and you have to stamp on this. You have within your means to put a thicker wall, to put a better grade, to demand 100% X-ray. Pipelines do not fail the way things do when it comes to rail cars. Rail cars are usually catastrophic, right? So when pipelines, we have enough leak detection methods, they can locate that leak very simply now, right? They can get out there, they can plug the line, they can fix it. People go, oh, well, it's damaging the environment. Well, once again, we're not going to kill people, right? Where a pipeline will rupture is probably a very remote area, because to come through a city, to come through a town, the wall is beefed up, everything is beefed up. The amount of systems that we have to put, isolation valves, emergency shutdown valves, these rail cars don't have it when they come off the tracks, right? So I could control my design. I really can. I don't know what's going to happen. I'm not a train conductor. I don't know what they have in place to prevent that train from coming off. I don't know how it is, but I do know they're more devastating, their actions when that thing comes off, to the environment than when our pipelines rupture. Even at river crossings, because that's usually a very sensitive thing. Where there's river, we will be able to isolate. It is mandatory on both sides of the river that there is isolation. So should there be a rupture upstream or downstream, minimum is going to be released into that river. So we have a lot of tools available to protect our pipeline. And I don't know why. And the states, they're now starting. I was down there recently, right, Marco? We went down and they are now realizing we need to start putting pipelines in the ground because they're trucking a lot of their product. Railcar and trucking. We couldn't even cross this four-way stop. It wasn't a four-way stop. It was on a two stop. The trucks just kept on going. And I'm going, man, one pipeline, it's buried, it's forgotten, it's underground, it's monitored at the control centers. We didn't even have all this traffic, but they're trucking. It was unbelievable how much trucks were going by, right?
With the pipeline, you can minimize more human factors, right?
It eliminates it completely. It's all automated, right? You have your control centers. If there is a leak, you know about it, right? If a train gets off the tracks, it's usually more, I have not read where a town catches on fire because of a pipeline. I haven't seen one yet. Maybe there's one out there and it'll be nice if someone sends you something, right? But usually when you hear in Quebec or somewhere like that, you hear about this rail car that derailed in a town and it's catastrophic. You have to evacuate the town. You have to do all this crazy stuff, right? Because that track is going through, whereas a pipeline going through, it has to be beefed up. It has to have emergency shutdown facilities near it, especially when it's near an occupied center. It has to have all these other factors that prevent a major accident. Trucking now, I understand why you truck. You truck when you're first starting up, right? You're starting up this facility, right? You have the well, it's producing. You need some trucks. But after a certain volume, the traffic, just think about the traffic and the number of trucks that have to be on the road. Eventually, they have to go to pipelines. So pipelines, it's still it's the safest. I have not been, if I could, I would love to go into any conversation with anyone that tells me, hey, pipelines they're destroying the environment. The amount, when you see the care that a construction crew takes when they're out there in the field, it's incredible what they do. It's incredible what and no one's around to see what they do, but they make sure they're looking after that environment. When you put that pipeline, when they cover it over, you don't even know it's there, right? They reseed it. They actually reseed for the farmers. You don't tell it's there, right? So pipelines, I'm always, hey, that's my line of work. I've been doing it for so long, but I cannot justify rail car. I can't see for the amount of rail cars to load up, the amount of errors that could happen loading and offloading that product. I bet you those numbers are really high versus a pipeline that comes into a facility, it's metered in. Remember, when you do a rail car, they still have to do all the metering, they have to do all that. In a pipeline, it's already set up into one system, right? So.
Yeah, no, it's a great comparison. I appreciate that. So like when it comes to construction, it's always an interesting topic to discuss. Do you want to touch on some of the considerations when it comes to like construction as well too, whether like it's up north in Canada or like down south in States or elsewhere in the world?
You know what? All I could say is I have a lot of respect for those construction guys. I do. We design a pipeline, and when we go out in the field to make sure it's done as per our drawings or as per our design, we give those guys a lot of leeway because they've seen it all. I'm not out there to tell anyone, hey, matter of fact, I take a lot of advice from those guys. Sometimes we want to put this Z-band that might not be practical, and in the field they'll say, hey, why don't we try this? And I usually listen to what they say because these guys have seen it. They have seen so much, it's unbelievable. And I found that every one of these guys, all these different companies, and I've dealt with a lot of these companies, some of them not even around anymore or they have merged, their safety is paramount. They really take that seriously because they understand that their resources, their people, are what makes them who they are. So their safety and the environment. What they talk about in the environment, Marco, you cannot beat these tailgate meetings that I attend. It's amazing. We have our internal office meetings and we'll talk our safety meeting. My safety meeting is, let's make sure we wear proper footing, proper shoes so we don't slip on the sidewalk. And that's common sense, right? If I'm going out, but when you're out there, they have to be, okay, guys, let's take into account the power line, the 250,000 kV power line above our heads. Let's remember that we're near this slope. So their safety meetings really take things to a new level. So I think all the crews that I've ever visited or have the privilege to be part of, in wherever I'm designing stuff, I admire. I think they're all similar. They're always with the safety, and they're always concerned about the environment. And they want to get the job done right because you know what? You get that job done, you get another job. So they want to do it right. They're not looking to milk that client. They're not looking to find that. People always say, oh, those construction guys, they're looking to get a change order. Yeah, sometimes they want those change orders, but I have found they're usually legit. So on the engineering side, we might have missed something in that change order. I mean, in the design that they said, hey, it's going to cost our crews, we have to stop before we get a response. So that would cost, right? But I found most of them are legitimate, right? So that's all I really have to say on that one. A lot of respect for those guys, a lot of respect.
Right on, Bernard. But listen up, there's a lot of stories and interesting topics that you have covered so far. Is there anything that was like we haven't really touched on and you wanted to to touch on in this episode?
Well, you know what, our industry right now, it's under the microscope right now. I mean, we have the different mandates coming from our government, our oil, all these eyes are on our industry, which really does not need to be changed. I mean, we have countries, I remember 20 years ago, foreign dignitaries would come into Calgary to see how our AER, back then it wasn't called the AER, right? The Alberta Energy Regulators. to see how we function. Because it's not only government mandates in how we design pipelines, there's also industry input. So we have owners with the government coming up with the rules. So these rules, we can never say, oh man, the government's too hard on how we build a pipe. No, our rules it's a mutual consent. But because we have this new mandate with environmental, which again, I pointed on how I think we're so environmentally conscious when we build a pipeline. I think our industry is under a bit of attack, and we just have to kind of get together. We have to form that front and realize there's nothing to be ashamed of what we do. We have a resource that the world needs. We need to value that resource. And right now we're treating that resource as if we're ashamed of it. And that's just because of the thinking that has been coming out of our government right now, our current government. It's just the way they're thinking, they're looking at this as a dirty resource. And it's one of the cleanest. It's not coming from countries that infringe on human rights. It's coming from a pretty democratic country where we have safety codes. We have protection for our workers. I've been around and I've heard stories with other countries that I'm not going to name, but their workers are working. They don't have to have mandatory PPE. I have to shave if I go on a site. I have to make sure I have certain criteria before I visit a site. Some places you don't, right? So just all I could say is we just have to, right now we're in a little bit of we're under the microscope, but I don't think we need to change. I don't think we need to, because I think we already have the right formula for what we do.
That's awesome, Bernard. Thank you so much for your time and really appreciate it. And we'll hope to see you again and speak to you again in the next episode. And then as always, next time. Thank you, Bernard. Appreciate it.
Great. Yep. And if anyone has any questions, Marco, just direct them through you, right? And then, if I said anything that contradicts anything, I'd like to hear from it, because I've been proven wrong before. So this is not an ego thing, right? It's just that I would like to know if someone has more statistics on, for example, pipe ruptures versus rail car. I would love to hear that. But whatever questions they have, would gladly answer them. We could discuss them, and you could email the person back, and then we could talk further about what we want to do for other podcasts with going into technical design. We could do things like that. So yeah, I really appreciate it, that being able to talk out there.
Right on. Great. Thanks a lot, Bernard. So I'm going to stop the recording here now.
Yep.